Hello, dear aspirants. This is Dr. Sourav sir's class. We are solving our National Board of Higher Mathematics questions, which came for the PhD and entrance test. This question is from our 2015 paper. This question is from our linear algebra. So the question says that our let A belongs to our GLNR. That means general linear group of n order matrices we have which have integer entries. Okay. So our let B belongs to Rn, be a column vector. Okay. So also with the integer entries. Then which of the following statements are true? The first statement says that if our Ax is equals to B, so this is the system of linear equations, then the entries of our x are also integers. So if it is true, then we have to prove that, otherwise we have to give a counter example. So we are trying to find a counter example for this question if it occurs here or not. Okay, let our A be, yeah, that can be, let us 2i, let us be it 2i. That means it is our 2002. Then let our be the solution space be, yeah, that will be 1. Then what we will get? Then our Ax will equals to B. So our A is what? That is 2002. And that my x be our x1 x2 and it's equals to 1 1. Yes. Then our 2x1 will be equal to 1 and our 2x, yeah, that is x, yeah, so 2x2 is equals to 1. So our x1 we get that is half and our x2 which is also half. So our solution space, that means our x is now half and half. But they told us that our x are also integers. So as it is not as the both of the entries are not integer, so the first statement A is my false. Now we have to check the B and C. For the B, they say that everything is correct, but our X are rational. Okay. Then we have to check that what will happen. Yeah. Let me change my color. Okay. So, given that our Ax is equals to B and my X will be what? We can do this thing. We are only multiplying left multiplying the inverse of A, then what? Then our this thing will be y, so x is equals to A inverse B. Now since the entries of A are integers, all the entries of A inverse will be rationals, no? Yeah. So our x will be rationals. As again I am stating that as our all the entries of A are integers, then the entries of inverse will be what? They will be rationals. So the entries of x will also be rationals, no? Yeah, so my B is true. Now we have to think for our option C. Yeah. Option C says that the matrix A inverse has integer entries if and only if my determinant is either 1 or -1. Okay. So, what can we do? So, we know that the matrix A inverse is what? That is adjoint A by det A. We all know that this formula. So our adjoint A is what? Adjoint A will clearly have all entries integers because these are the cofactor. These the entries of adjoint A are the cofactors of the elements. So the cofactors are what? Let our this be a 3 cross 3 matrix. Then let be A, B, C, E, F, G and H, I, J. Okay. Then our A, then the cofactor of A will be what? That will be determinant of F, G, I and J. So as F, J, I, G all are integers, so the determinant will also be integer. So every entries of this adjoint A, that means the cofactors are my integer entries. So my A inverse has all the integer entries. My if and only if, and we know that the integer entries of A inverse will take place when our mod A will be plus or -1. Otherwise, if let us take our entries of A inverse be this thing 2 3 -4 blah blah blah, and our determinant of A let be 2, then this will be my 3 by 2, so that is not possible here. So only possible case is my determinant of A will be plus -1, then the solution will take place and our entries of A inverse will be integer ones. Okay, this is my, so this thing is my necessary and sufficient conditions for A inverse has integer entries. Okay, hope you understood. Thank you guys.